Cool. So yeah, hey everyone. My name is Elliot Hesp. I'm the CEO at Invertase. I'm also a Firebase Google developer expert. You can find me on Twitter, GitHub, or just email me at elliot@invertase.io. So this session is called Journey into the Flutter ecosystem. So what does that mean? Over the last few years, Invertase, we've kind of become heavily involved in various technologies, working with different clients, one of which is Google. And we've taken on the development and maintenance of a Flutter package called FlutterFire, which connects Flutter applications with Firebase. I'll assume people know what Firebase is, but for those that don't, it's a suite of services which helps developers integrate with various Google services such as analytics, authentication, and different databases, and loads more. I'll be going over the challenges we faced, some insights, some of the solutions we developed, and the future plans we've got for Flutter. So quickly, who are Invertase? We're a UK-based company. We employ globally, and we're fully remote. We focus on building developer tooling, integrating different software together, generally to help make the lives of developers better. We're open source first, meaning we always aim to make sure our software is freely available and open source. A lot of our software is developed from an internal problem we faced, so we always make sure the team can work on these open source tools or even their own open source software. We're also on the lookout for developers too, so if you love open source, give me a shout. Cool. So before Flutter, so we were heavily involved in like PHP, JavaScript ecosystems, working with some golden oldies such as like Angular and CodeIgniter. We also worked quite closely with Redis, and we dabbled with Android and iOS development, but I gotta say it was nothing serious. We built some pretty popular open source libraries, one called R-Dash, which was like a responsive dashboard for Angular, React Native Material Design, which is like now archived, and then we soon began to spend a good amount of time on React Native. And I know this is a Flutter talk, so bear with me, but we've been working with Firebase for a very long time, and we built some large corporate solutions around it. In late 2016, we started a library called React Native Firebase, which does what it says on the tin, connects React Native with Firebase. Kind of over a 6-month period, the library, really grew in popularity, steady contributors. We built official documentation, testing, etc. And fortunately, Google reached out and offered some financial support to make sure the library was actively maintained. And for the unknowing, it's an absolutely massive library. There's loads of code and just some really complex challenges. So this was massively helpful to us. React Native Firebase is one of the largest third-party React Native libraries, downloaded over like 850,000 times a month, used in really popular applications, and kind of shaped the development of React Native itself. And we had some unique problems to overcome. 5 years later, it's in a really good place. Runs like a well-oiled machine, and it's got regular releases and fully automated testing. So this is a Flutter talk. How is this relevant? So our introduction to Flutter. Our experience with building React Native Firebase allowed us to gain a lot of in-depth knowledge of the Firebase SDKs and the challenges integrating them with a cross-platform solution. We've been keeping an eye on Flutter for a while. However, we hadn't seriously used it for anything. In early 2019, the Flutter Firebase integration named FlutterFire was in development. However, it was more of an unofficial solution built by Googlers and contributors. Generally, it was lacking behind in features. There were like 900 issues on the repository. The API was inconsistent. It didn't really match any of the existing Firebase SDKs, so developers had to learn a brand new API specifically for FlutterFire. And crucially, there were no tests or very minimal ones at that. Another aspect during this time was something called plugin federation, which is a package architecture strategy for Flutter, which enables packages to support any platform, and it was starting to become mainstream. Some of the packages on the repository were federated, some weren't federated, and some were mid-federation. So with no tests, it was really tricky to actually rework the packages and just generally accept PRs. So, I mean, all this is pretty understandable. You know, it does take a lot of time and resource to upkeep a repository of that size. Because of the similarities of React Native, Firebase, and FlutterFire, there were a number of places throughout the code base we saw areas for improvement or general issues we'd already solved with React Native. So we reached out to a Googler. We had a prototype of how we could go about sharing native code, so that's just Android and iOS at the time, so that it would work on both React Native and Flutter, having one native code base. Generally, like, the idea worked quite well. However, it proved tricky to move ahead with because there were like outstanding questions like who would own the code, who would maintain it, you know, where does it live, and we couldn't really come to an agreement on any of them. So almost a year later, the talks turned into an agreement where we began working with Google on FlutterFire, and that had the following goals. So this was bring FlutterFire to a 1.0 stable release, and by stable release I mean like production quality code for Android, iOS, and web. Fully tested, so that's end-to-end tests, unit tests, building a dedicated documentation website, you know, full of examples and guides, triaging open issues and pull requests on the repository, you know, identifying what the common problems were, and at the time there was like over 1,000 in total. Reviewing the existing APIs and designing a new public API which users should feel comfortable with, so there was something more Firebase-like. Federate all of the plugins, so essentially this meant creating a public package, a platform interface package, and a web package, if that was applicable. So generally this was like a really big undertaking, and honestly we didn't really have a huge amount of Flutter or Dart experience under our belts at the time. So, yeah, opening a can of worms. So a lot of the goals I mentioned before were pretty straightforward. You know, building a documentation website, reviewing and designing an API, triaging issues. We knew exactly kind of how to go about achieving them and generally the effort it takes to do that. Coming from JavaScript land, we had a fair few tools that were well established at our disposal, which were tried and tested. For example, we had like Learner and Yarn workspaces, which helped manage monorepos. You could automate releases, run tests, and then also you had a framework called Jest, which is a really solid testing framework for JavaScript. Once we started getting into the project, it soon became clear that there were a fair few challenges that we hadn't expected. So overall, we felt that the developer experience for building Flutter applications itself was really good. However, the experience for building packages was not so good, or at least when you were working on multiple at the same time. So what were the challenges we faced? The main one was local package development. So FlutterFire supports 17 different Firebase services. Each service, minus Crashlytics, supports Android, iOS, and web. So with plugin federation, each service requires 3 sub-packages. So that's a public, an interface, and a web package. For FlutterFire, that's 17 multiplied by 3, minus 1 for Crashlytics, and that's 50 individual packages which needed to be developed on the same repository and all published to pub. So you're locally developing packages for Flutter. You can provide a path to the local package in your pub-spec file. Pub will install from the local path, and the Dart analyzer will read from there too. So great. So we've got a solution for developing all the packages together. We change 50 pub-spec files, all to point internally to each other. Well, not so fast. So you can't publish to pub with a path in the pub specs. So that means we need to change all the pub specs back again, before we publish. So change them back to a version. And if we're supposed to be running tests, we've got a CI. So we want the CI to also run the tests against the local packages and the changes. So we need to push the pub spec changes with the local path to the repository so the CI can pick them up so it can work with the local changes. But then we need to change them back again to publish. So yeah, not particularly great. as you can see from the slides here, like on the left, I know it's not very clear, but we've got the Firebase core services. On the right is like one of the Firebase packages, Firebase auth. And all the lines connecting are all the different dependencies they all have on each other. So it gets pretty confusing. Another problem we had was scripts. So coming from JavaScript land, we'd add a script to a package JSON, which is basically like the pub spec, and we run a command to run that script. So npm run test. But this doesn't exist for a pub spec file. Some of the scripts for FlutterFire were pretty long and complicated. For example, we'd want to run tests against web, spawn a Chrome driver instance on a specific port, run tests for a specific package, and then start the Firebase emulator suite. That's like a lot of commands and arguments to remember. We created a Google Doc to store these in at the start, which it worked okay, but then it meant like external contributors couldn't really see them or understand them, so it wasn't really a great solution. This also meant that on the CI, we had just like loads of random scripts and arguments all over the show, and it just didn't really mean much to contributors, and it was, pretty unmaintainable. Okay, so we've got a sort of workaround for local package development, and now it's time to release the packages to pub. Okay, so everything's ready to go, so let's go and increment the version of the packages. Right, as mentioned, we've got 50 packages on the repository, some of which have dependencies on each other. So imagine this scenario. Package A updates and increments its own version. Package B, which depends on A, so that needs to update the dependency of A and then also update its own version too. And then you've got package C, which depends on B, so you need to update the dependency of B and then update the version of C as well. So yeah, that's going to get pretty complicated. And I've not even touched on the fact that you've got A, B, and C, which are all different, major, minor, patch versions. And in fact, like FlutterFire dependencies are way more complicated in that scenario. So it was really complicated. So let's say you painfully work out what versions need incrementing and you don't make any mistakes. Great, yeah, it's time to publish. Well, you can't just write a script to run through all the packages and just publish them all at once in whatever order. Pub will publish them fine, but the metadata generated by pub after publishing will be incorrect, or just simply fail to generate, meaning things like API reference docs just won't be correct. All right, so that means we need to publish them in order to get things working. I mean, that's going to take a long time for 50 packages, and let's just hope we don't screw something up along the way, like get the version wrong or publish them in the wrong order. Another challenge we faced was change logs. So a contributor comes along with a bug fix, increments a package version within the pub spec, updates the change log with that version and the change details. Great. Now, what if a different PR is merged in before that? We need to ask the contributor making the original PR to update the version, then update the change log with the new version and resolve all the conflicts while they're at it. So this isn't great, and it doesn't really help with encouraging external contributions. They need to know the existing versions, what impact their change has, versioning semantics, etc. So assuming it gets merged in, we'd personally then need to work out what dependencies need changing in the other packages and update them too. So, really, really complicated. Things just kept going wrong. So for a while, we dealt with these issues. We had some hacky workarounds. However, it just generally degraded the overall development speed, and there were just manual errors being made. So Melos. Melos was a package that was born out of frustration. We were used to really good development experience with React Native Firebase. We had fast, efficient release cycles, and this just was not happening on FlutterFire. So what is Melos? It's a package we created to solve these problems. It's written in Dart, and it's specifically for Dart and Flutter projects. Think of it as a mono repo management tool. It's a CLI package published on pub, and it's inspired by Learner, which is a JavaScript tool I mentioned, which accomplishes these problems. And it's also runnable on Linux, Windows, and CI environments. So what problems does it solve? It enables repositories to be structured as monorepos. This is commonly where all the packages are stored in with like a packages directory, a subdirectory in your repo. It automates versioning and changelog generation. It automates releasing multiple packages at once to pub. It locally links your project dependencies together. You can define project level scripts, run them with a single command or on many packages at once. It exposes useful runtime variables which are useful on CI environments. For example, like the current package version when you're executing a script. It integrates with VS Code and Android Studio. It exposes useful utility commands such as listing local packages, the versions, subdependencies, and it allows you to define glob filters. So you could, for example, ignore example directories or packages when publishing or running tests. So how does it work? Well, firstly, on the right, you define a melos.yaml file within your repository. So you add your project name and where your packages live. Melos scans your entire project for packages, building up a local matrix of information, such as like the package name, the versions, the dependencies. It overrides some core files used by the Dart analyzer, which allows packages to be locally linked together without editing any pubspec files. And this also works on CI. Optionally, you can use the conventional commit standard. So Melos understands what commits impact what packages, what the change was, and what sort of changes is required for the version, whether it's breaking, major, or minor. Using the sort of internal matrix of packages, it's able to automatically version packages based on a conventional commit, but it also understands what subdependencies also require a version bump too. It can apply these changes automatically by editing the pubspec files for you. It'll automatically generate per package changelogs and also root changelogs as well. And using all the above together, it'll then publish the pub for you in the correct order. So even though like Melos is fairly young, it's sort of coming to 9-10 months old now, it's already being used on some large repositories such as FlutterFire, Amplify, which is the Firebase alternative by Amazon, the Flutter Community Plus plugins, Stream, Flutter Stripe, Riverpod, there's more too. So the FlutterFire development experience. Overall, the development experience for our engineers on the FlutterFire project has been massively improved. The dev speed alone means we're fixing more issues, adding more features without spending time setting up, configuring the local environment, figuring out how to run tests, and most importantly, being able to efficiently publish and version packages, multiple ones at the same time. And that just takes minutes versus hours. The development workflow between ourselves and the community has now been standardized. Contributors have the exact same setup as ourselves. They can run the same complex scripts with minimal effort, meaning they can execute tests locally, start emulators, etc. On the slide screenshot, this is an example of Melos listing out some of the available script choices for FlutterFire. So don't know if that's visible, but there was like 19 different scripts and they all run really complex tests. So all you do is bop in the number and it'll execute them. The great thing about Melos being open source and package agnostic too is that with the plugin federation setup, it's now painless to migrate packages to them. This has enabled other package creators to break out their own packages into a mono repo and migrate them to the federated setup with ease. In May, Flutter 2.0 was released. In line with this release, we managed to ship loads of new features to FlutterFire. We reduced the issues and PRs on the repository by over 85%. We carried out work to migrate all the packages to null safety. We added new features such as like a type-safe API for Cloud Firestore. We supported all the Firebase emulator suite. We migrated all of our tests to them too. We added support for the new AppCheck package for Android, iOS, and web. Moving this quickly would not have been possible if it wasn't for Melos, so we're super happy on how the project has helped us along the way. And over the next few months, we aim to have all the Flutter plugins in a stable state. So what else is happening? Another project we're super excited to be working on is FlutterFire UI, which will again improve the development experience with FlutterFire. So much like its web and native counterparts, the UI package will enable developers to integrate complex logic flows which are common for many applications. For example, if you're building an application which requires authentication, you'll more than likely need many custom screens and widgets to achieve common scenarios such as email password login, forgot password, creating an account, social login via Google, Facebook, Twitter, and that includes setting them all up, adding the SDKs, the configuration, linking multiple providers with one user, validating user input and handling handling application states such as errors and loading. Phone number sign-in, so entering a phone number with a list of country codes, waiting for the SMS to arrive, allowing the user to enter the phone number, but also handling things like auto-verification. So ensuring all of this logic is implemented in an application is really time-consuming, and it can be pretty complex. FlutterFire UI exposes a set of high and low-level widgets to help developers speed up this implementation. So by high level, I mean fully fledged pre-styled widgets which create an entire experience for users. For example, a login form which handles errors, loading states, social auth providers. You can simply drop a widget into your application where you see fit and everything will work out the box. Behind the scenes, it will work with the FlutterFire auth package, so you can use the two side by side. On the other hand, the low-level widgets provide the building blocks of FlutterFire UI. However, they're exposed to the developers, allowing you to integrate the logic the package provides with your own UI and widgets. For example, with phone authentication, a authflow builder widget would return contextual information from Firebase about the current state of the flow, such as whether an SMS has been sent, whether an invalid code was entered, or it was successful. From that widget, you can then instead return your own widgets, which handles the state. So this should significantly help reduce boilerplate code. Although it's not available yet, we're hoping that a release of FlutterFire UI will be available in the next couple of months. And for more information, you can check out invertase.link FlutterFire-UI. Cool. Another project we've been working on is FlutterFire Desktop. So officially, FlutterFire only supports Android, iOS, and web. However, with the work we've been doing, soon all the FlutterFire packages will be federated. So the FlutterFire Desktop project aims to bring support for FlutterFire to both Linux and Windows by building on top of the federated plugins. This will allow for seamless integration with the existing applications using FlutterFire. The package will be a pure Dart implementation of Firebase. However, it provides platform-specific support for Windows and Linux to solve challenges such as deep linking, social provider handling. We've just open sourced the repository with core and auth support being in an alpha state, and over the next few months, we aim to get authentication into a fully usable, tested state, which can then be consumable by the public. We'll then aim to bring support to the other popular Firebase services such as Firestore, Cloud Functions, and Storage, with the rest to follow afterwards. Also, we're proud to announce that Canonical are sponsoring us on this project to help bring FlutterFire to support all the platforms which Flutter itself supports. Another aspect of building FlutterFire, which wasn't as straightforward as we hoped for, was testing. A lot of the focus on building tests for Flutter was around widget testing, rather than actually testing the packages themselves. Test commands were long-winded, the output wasn't very readable, especially when you've got hundreds of tests. We kept experiencing false positives, so failed successfully tests. There was no way to isolate tests, so we'd only want to run a specific test. To do that, we'd have to comment out loads of code in different files. There was no way to quickly rerun only failing tests. There was no code coverage when running integration and E2E tests. An E2E test had to be run from an example application where our unit tests were in the root of the actual package. So we've started working on a new package called Spec, which is a Jest-like tool for running tests. For those that don't know, Jest is a very popular and awesome testing library for JavaScript. The goal of Spec is to be simple. Run a single command and experience a great developer interaction workflow. The high-level features of Spec will be a type-safe API, an opinionated API. However, it will be built on top of the existing Dart testing tools. Right now, there's many ways to test different Dart concepts, such as streams. Spec aims to provide an API so you don't write bad tests, failing tests, or flaky tests. It'll have an interactive CLI. So this will allow you to do things like quickly rerun only the failing tests with a single key press. And a pretty output, so you can actually identify a single failing test out of hundreds with a clean, simple output of the issue and the location of the test. I did have a quick example, but I don't think I'm going to be able to run it on this. So Remy, who's been working on packages such as Provider and Flutter, Provider and Riverpod, has been working hard on this over the past few months. We're hoping to have it open source and integrated with the FlutterFire repository, mainly as a dog fooding activity, by the end of November. So we're excited to see how it goes. Oh, I think that was a... So you can see if that runs, yeah, example of it all running together with groups, failing tests, nice clean output, which isn't currently what you get. Cool, so that brings me to the end of the talk. It's been an enjoyable journey coming into the Flutter ecosystem, especially after being really invested in React Native. I'm excited to see the future of Flutter and what else we can do to help the ecosystem. If anyone's got any questions, please let me know, or just feel free to reach out to me on email. Thank you. Cool. Yes?
I was interested in, you did a lot of work to make the Cloud Firestore compile faster.
Yep.
Is the plan on making it better?
So Cloud Firestore on iOS is from memory, it's got a huge size when you install it, and it can really sort of, you can make the build times huge. So what we did is we basically have a script that automates it picks up new releases of the iOS SDK, the official ones, and it kind of like bundles them into some state. iOS isn't my strong area, but that is more of not a FlutterFire specific solution. So what we did was we made a solution which was just platform agnostic. So the binary, I think it is, that we produce is usable on like FlutterFire, and it's usable on React Native Firebase as well. Hence the reason we did it. And in terms of making it faster,
Have you considered, for example, like light packages? Or like,
Yeah, so I think that's mainly probably comes back down to the actual Firebase team doing that. They've done that for the web. We've not had a talk with them in a long time about the iOS build, but yeah, it's probably something we can bring up again. We have had, months ago we were talking to them about how we can improve the speed, so it's probably a good one for us to bring back up and see if we can make it even faster. Hello.
How did you deal with YAML round tripping for Melos? Because we've struggled with that and ended up using Python in some of our CI.
So how do you mean by round tripping, sorry?
So when you've got your pub spec and you've got local dependencies or pub dependencies in it, and you're kind of trying to switch between one and the other,
Yeah.
you end up wanting to round trip the document between a local pointing version and a pub pointing version.
Yeah, so we struggled on this for a while, and honestly, it was we hacked together a solution in the early days just to get something working. Long story short is that we figured out that when the Dart analyzer runs, there's like a load of like internal files it creates when you like run, pubget or whatever, and it points to the location of them, like the remote repository, and we basically just hijack them files and we override them for only the local packages. So any other ones you install still point to pub, whereas ours we just reroute everything to point internally. It was a bit of a hack, but it works quite well. Okay.
there any chance that, or in the future, that will be the case for the mobile version?
Yeah, so that's a good question. So this is a topic that comes up quite a lot actually. So it is possible to make a Dart-only implementation for Firebase services. So if you think like Cloud Firestore, there's not really anything super special going on under there. It's making a network request at the end of the day. So there's no reason that can't be Dart-only. And yeah, like that the plan is we build a Dart-only implementation, and then for FlutterFire, we simply just switch off the native ones and point it all to the Dart-only implementation. When it comes to other services, like take messaging for example, that I don't see how it could be Dart only, because you're dealing with FCM and like the internals of creating a local notification on Android and iOS, and I don't see how Dart could do that without having a native layer. But definitely some of the services are feasible to make Dart only. Then you've also got ones like Cloud Firestore. So yeah, technically it's possible, but when you look at what the SDKs are actually doing, they do a lot of complex work, like offline only mode, like caching. Those things, yeah, they're doable, but writing a Dart SDK to do that is an absolute mammoth job. We have looked at it, and I know there's been community kind of people trying to do that themselves. I think Raz has done a solution, but the amount of time that takes to do is just huge. And right now it's not on our roadmap because like I don't think Google are interested in it at the moment, and we're not interested in like self-funding that because I don't want to know how much time that's going to take us. Hey.
Question regarding what was the thought process behind going for the Dart-only implementation? Because the current way the plugins work, it works, and the C++ implementation of Firebase was before the only stub implementation. It's not in beta, so where I was sitting, it sort of looked like that would be the way to go.
Yeah, so Firebase shipped the C++ packages, and we've had many a chat with them about them. However, they are the general understanding is that they're designed for games development, and that they miss core features. So from Firestore, you've got all the different query capabilities, but the C++ just doesn't support that. And as far as I'm aware, they've got no plans to support that. So although the C++ packages could solve problems, there's just too many like holes that we'd need to fill, and I don't know how we could do them using that implementation. So the idea being is we use the like underlying GRCP packages and kind of interrupt them with Dart, and that's kind of the way we're planning to do it. Cool. Any more? No? Cool, thank you.